So please welcome to the stage Datadog's Matthew Mills and Ryan Simon.
Innovation happening in organizations occurs on a pretty consistent basis. There's always new methods that companies use to deploy new tech stacks and applications. A new one that is oncoming is what's known as sort of cloud native workloads. I'm sure some of you have heard of that, but our talk today is going to be discussing cloud native workloads, some of the challenges organizations face with defending cloud native workloads, and some solutions that I think that we could use to help make that a little bit easier for defenders. Before we go into that, first, let's talk a little bit about who we are. So my name is Matt Mills. I am an Air Force veteran. I've been in the information security space for about 12 years or so, primarily around the detection and response space.
I'm Ryan Simon, also a product detection engineer with Datadog. Been in kind of the cloud security space for about 5 years.
We had a third colleague with us today, but they're sick, so unfortunately they won't be able to join us. So as I stated before, a new domain known as like sort of cloud workloads or cloud native deployments has been pretty emergent. I believe the last time CNCF did, which is the Cloud Native Computing Foundation, did a survey, there's currently around 20 million cloud native developers, and that number is going to be growing every year. So with the rise of this new information domain, as always, there's going to be a rise of threat actors aimed at targeting that domain. So one of those threat actors that we're going to be talking about today is known as Scarlet Ill. So some of the tactics Scarlet Ill uses can map directly to the MITRE attack framework. So some of the things that we see them doing is exploiting Jupyter notebooks in containers as their initial access vector. From there, they're known to do things such as install crypto miners, use IMDS to gain access to your cloud services provider, specifically AWS, and then install additional tools such as the AWS CLI, Pacu, and Perimeter-centric, which is like some pretty well-known pen testing tools. And we're going to get into a little bit about what those things do later. The important thing to note, though, is that these attacks are happening at a steadily increasing basis. We believe that reporting on these attacks is pretty sparse, mostly because these organizations who operate within cloud native specifically aren't necessarily equipped with the best tools to defend against these attacks or even detect them in the first place. Our talk is going to primarily revolve around what some of those challenges are and what are some things that we can do to make this easier for defenders in the wild. So what we're going to be covering is specifically what exactly cloud native is. Again, we're going to go into some of the challenges that are specific around securing cloud native workloads. And then we're going to take some of the existing attack matrices today and then apply them to some of the tactics that we've seen Scarlet Ill using.
Yeah, so as Matt said, we've seen kind of that trend towards cloud native in software development and software deployments. So with that, we've kind of defined kind of 5 architectural principles that kind of underline cloud native. First, we have containerization, basically packaging your applications and configurations into containers to make them more portable. Elasticity, basically shrinking and scaling your resources at runtime to take advantage of the cloud. Microservices, breaking those applications down into smaller independent services. Highly automated, basically breaking down any manual steps into configurations with scripts or infrastructure as a code. And finally, orchestration. So basically tying that full life cycle of the application into one kind of orchestrated product. If we kind of go down into look at the individual cloud native components, there's a few things that we see. So first, we kind of have our compute resources within our cloud service provider. With that, it's probably going to be running an operating system. Traditionally, that has been Linux. Obviously, there's more trends towards maybe a Windows or BSD, but by and large, that's going to be a Linux distribution. Then we have container runtimes, right? So those are broken down to high level and low level runtimes. You may have all be familiar with Docker. That's kind of the name brand out there, but there's other runtimes. From a container orchestration product perspective, we see Kubernetes, and Kubernetes actually runs the containerd runtime. From there, we kind of have our containers running those container images. That's where you're going to store your application code, your dependencies, and your runtimes. So this makes them highly scalable. They're not virtual machines. They use a limited resource set, so you can really have a high density on your clusters. Limited isolation. Containers are not a security boundary. If there's exploits against the kernel or the container runtimes, or if you have a misconfigured container, they may be able to break out into the underlying host. And then high portability. Because we've packaged all the runtime in code, basically we can port it from our developer workstations, maybe on an on-premise server or a staging environment, into our production cloud. If we kind of look at a kind of a sample of a cloud native architecture, we kind of see a few things laid out. We see kind of our cloud provider APIs. Basically, that's where you're going to see your access control, other resource accesses like storage or container registries. That's, again, where your cloud responsibility model will lay. But then we also have our clusters, and our clusters are obviously running our containers, which then run our container images where our applications live and our microservices are at. So I've talked a lot about different components and different layers. So we do see some challenges when we talk about securing cloud native workloads. Obviously, the complexity is one thing to highlight. The different microservices, the different layers we look at creates very complex systems. Second to that is velocity. Obviously, with the introduction of APIs and CI/CD pipelines, developers are pushing code as fast as they can. On the flip side to that, we also see attackers making use of that same automation and the same APIs to start attacking our cloud native workloads. And then finally, we see visibility, right? So we have multiple resource stacks. Those resources might be owned by different teams. So trying to find who has that ownership and what's actually happening and where it's at is a challenge. So we like to kind of break it down into the mental model of 4 C's. So we have code, container, cluster, and cloud. As detection engineers, we kind of look at that telemetry that gets generated, our application events, OS events, our orchestrator logs, and cloud auto logs. So we kind of need all of those from a defense perspective. If we apply that to the previous diagram that we showed earlier, we also see cloud, cluster, container, and code kind of laid out in that full architecture diagram. So what applies today from a matrices standpoint? We have Linux, containers, and cloud or infrastructure as a service. So the state of relevant techniques is kind of across our different matrices here. But to kind of break it down, we look at it as relevant techniques and not relevant techniques for cloud native workloads. So if we're drawing from multiple matrices, we can start with kind of the Linux matrix itself. So relevant, we kind of have exploit public-facing application. That's always going to be relevant. Then we see something like phishing that is somewhat relevant, not maybe directly to the workload, but maybe from a developer's standpoint of trying to get their credentials. Hardware additions, again, the cloud responsibility model, probably physically not going to be able to access the hardware to make any additions. From a credentials access standpoint, we see maybe credentials and files, but there may be better opportunities out there. Input capture, again, because of the highly automated nature of cloud native workloads, input capture is probably going to be out of scope. And finally, network sniffing, it could be relevant, but it's a very challenging thing to pull off within a cloud native environment. So if we replace our credentialed access with cloud instance metadata, that's probably going to be a better opportunity to understand how those cloud native workloads access their credentials. So if we look at it kind of like this, we have our Linux techniques applied with our infrastructure as a service techniques. So today we want to go from here, where we have to go across our multiple matrices to understand those techniques, to here, where we go to a consolidated cloud native matrix. And I'll pass it back to Matt to kind of discuss a practical example of attack.
So earlier we introduced this actor Scarlett Ill and talked about some of the actual tactics they're using when compromising cloud native workloads. We're going to show you some of the pain that some defenders may have using the matrices as they are today to prepare themselves against threats such as this. Let's take for an example the scenario that we showed earlier. As we stated earlier, many of these tactics flow across various different matrices, and so you would need to be able to look across all of them in order to start building things like detections and security controls to account for some of these tactics. So for an example, in our Scarlett Ill scenario, they actually exploited containers running Jupyter notebooks. That falls squarely within exploiting public-facing containers, which exist within the Linux and containers matrix. But then we look at some other things that they did. For an example, they used IMDS in order to pivot from the workload itself to the AWS instance. That falls within unsecured credentials or cloud instance metadata service, which falls within the cloud or infrastructure as a service matrix. From then, we see things such as installing crypto miners, which falls within resource hijacking, using tools for cloud service discovery, which falls, again, cloud service discovery, infrastructure as a service, and then things such as ingress tool transfer to install things like Pacu and Perimeter-centric to do additional attacks against that infrastructure. The problem that we're identifying here is, again, for a defender to be able to prepare themselves appropriately, they would need to look through various different matrices. And that can be a bit of a challenge sometimes. Again, all of these, as they fall through those different matrices, in order for you as a defender to ensure you're protected, that means you might have to crawl through every single tactic within each of these matrices to ensure that you have decent coverage and detections against this. The problem with that is the only way for you to know for sure is you would potentially have to crawl the entire enterprise matrix in order to validate that coverage. That can be a bit of a challenge, right? That's not, especially when we look at some of these developers who are actually migrating to and deploying like cloud native detections. Many of these are dual hat individuals, which means they're not primarily security. So there's already a challenge with just understanding the information in the matrices themselves, along with their additional duties. Adding all of this capability together can be a little bit of an information overload, which is what leads to the challenges we have with defending cloud native workloads already. Now, there are things that are being done to address some of the visibility gaps and the lack of reporting on like attacks happening in cloud native workloads. But at the end of the day, it is still a pretty significant challenge. Some of the other issues that we have with the enterprise matrix is out of 185 total techniques and 367 sub-techniques, that is a lot of information for someone who is not primarily in a security role to have to go through and parse. On top of that, we've stated earlier that a lot of these techniques are likely not even applicable to the cloud native workload as it is. So a lot of this will be just a simple waste of time. And then on top of that, like I said, most of the people who have to do this work are not like primarily security focused individuals. There are a lot of times they're dual hatting. So they may not even have the expertise to identify which of those tactics are actually important for them to evaluate in the first place. Some of the benefits that we get from creating a cloud workload matrix is we can scope this down to just what is relevant. We don't want to go and say specifically everything that is relevant because we don't want to sort of like, it's probably a pretty ego-driven thing, right? So we didn't want to state like a specific number of techniques that we feel is relevant because there could be gaps in our understanding. But so we really think this should be like a community-led effort that everyone can contribute to generate a product that can be useful. If we can scope that to just what is relevant and detectable at the runtime, this can be really effective for developers, especially as this whole industry of like cloud workload protection products are being generated. Oftentimes, customers will have to ask the question or have the task to evaluate the effectiveness of that cloud workload security product, right? The problem that comes across is they don't know what's relevant. So they end up testing everything and generating a ton of noise and making everyone's lives difficult from a detection engineering standpoint and a security control standpoint. Creating just this cloud workload matrix can save defenders time and pain from having to evaluate and have coverage for inapplicable techniques. So again, creating this cloud workload matrix will provide like a concise grouping of tactics to sort of enable defenders to be able to more effectively defend their cloud workload deployments. So we have started a little bit of this journey already. We've created a repo where we have identified some tactics that probably are not relevant to cloud workload or cloud native deployments as a whole. Again, though, we've just started this initial work. This will require a pretty significant community investment to generate something that can be useful and applicable to all. Along that same line, we are started to working on a tool that can emulate some of these tactics in customer environments as well, so customers can use this to test and evaluate their security controls and detections. So some of the key takeaways of things that we've talked about so far is that cloud native environments are pretty complex, but we can simplify this by breaking it down into the 4 C's of code, container, cluster, and cloud. These workloads oftentimes will intersect multiple matrices, primarily Linux containers and cloud. However, there's even more a potential opportunity out there, right? There's things such as the Kubernetes matrix, primarily built by Microsoft, which can definitely apply to here as well. There's also the sort of like ugly stepchild that nobody likes to talk about as far as like Windows containers. That's a whole threat model that is growing every day that not a lot of people talk about or even have coverage for. That's also something that can be fit into this model as well. Additionally, if we can identify these tactics and then highlight just what is applicable at the workload level, we can create a tool that we know our engineering and security professionals need to protect and defend their cloud native workloads. Thank you for our talk, listening to our talk. We have a QR code here that will provide a link to our workload protection tool. Again, this is something that we think community needs to have like a pretty significant input in, and this is something that could benefit us all. Thank you.
Thank you both so much. That was excellent. And I love, it kind of almost ties back to what Casey was talking about earlier with, you know, what we see in attack in terms of these clean delineations between mobile and enterprise and ICS, and even at the platform level, doesn't represent reality. I think exactly like you said, not only is it much more complex, it's much more hybrid, it's also very kind of, you know, confusing. You know, and I think that's the core of my question. We do have a little bit of time for questions, so start to get these queued up. But what I thought was really interesting about your talk is, even a couple times yesterday, we've talked about threat modeling in terms of the importance of seeing your adversaries, thinking about their tactics, techniques, procedures, their behaviors, and how are you going to defend it. But I think what you really highlighted was the other side of that, of looking at yourself and saying, how do I understand, like even looking around this room, like what's here to defend? What is our stuff? What is your advice for folks, especially even tying into your project, like starting to step into that space of like, hey, I'm maybe a team of one, or we're a pretty small team, we have this enterprise to defend. How do I start? Is it asset management or good documentation, a little bit of both? How do you kind of venture into that space?
So like any security professional, the first thing that we would always recommend is the whole concept of defense in depth, right? So the first thing is evaluating what assets you have to protect and what security controls will be applicable to those assets. Now, we can all talk about like a perfect world, right? But we know we don't actually exist in that. So we can't always apply the very best security controls. And that's the reason why detections exist in the first place, right? There's always going to be a security control you can implement effectively. The first place to start, though, is identifying what security controls you can implement, and then begin building a detection strategy to account for what you cannot address by a security control. A lot of organizations sort of like inundate themselves with trying to create a detection for everything. And while that's probably a good place, like as like an objective goal, that's definitely not where you can start. First, start with what security controls you can implement, and then create detections to address what you can't. And that's where I would recommend most people to start.
Excellent. I don't want to monopolize all the time. So if anyone has any questions, thoughts, otherwise I can just. Okay, awesome. So really interesting thing about when I always think about cloud, and especially the kind of scoping of systems you're looking at, is that shared responsibility model. And you talked about controls and protections. In your, especially working at these cloud like workloads, like how have you navigated that space in terms of, you're highlighting, long, excellent list of here's our risk, here's our threat model in terms of TCPs. How have you navigated that kind of, okay, we've done as much as we can, but we really need you as a provider to kind of meet us in the middle, whether it's additional logs or additional settings to help, mitigate things. Any advice, tips for folks? I know that's very often a hot topic and maybe a roadblock a lot of us run into.
Yeah, no, I think it's a very challenging problem to understand kind of that intersection on what the cloud provider needs to provide us versus what we can provide on our own. We've run into those same challenges of trying to get that data back into our own platforms and try to understand what is relevant. And I think it's also ever changing. I think that's the challenge with the cloud, is that at first maybe some people are running like their own bare metal clusters for Kubernetes or something like that. But now they've shifted to like managed Kubernetes, which kind of creates a different layer of like patching, and it's handled by cloud service providers. So I think you're kind of at an arms race to understand what are those changes, what is everything going to, versus trying to get the data that you can get within there.
And how do you prioritize that? Because especially like, it seems like in your arena, you have like point in time, you're able to model everything, you're able to look at techniques, and maybe even look, hey, phishing versus, you mentioned like exploitive external facing, infrastructure. Like, okay, like exploits for initial access is probably a little bit more higher priority. But as things shift, do you have like a process, any type of, or is it just kind of a gut check of, okay, like let's, evaluate how things have changed and then maybe figure it out? Is there any pro tips in that space?
Oh, there's definitely like a process to sort of help prioritize these things, right? The first thing starts with, as you said before, is like generating that threat model in the first place, right? This all starts with identifying what's actually a threat to your environment, right? So when things change and new techniques are developed, and you're trying to like identify what you need to prioritize, part of that threat modeling is like assessing what the impact of that specific threat is, right? And so you can prioritize just from that alone, right? So like, let's say for an example, a new initial access vector is discovered. You can sort of like prioritize based on what is it that initial access vector actually requires to be exploited in the first place, and then validating whether that's something that actually applies to your tech stack. Using methods like that, like I said, using that threat model, assessing like what the actual reach and impact is how you can sort of identify what you need to target first.
That makes sense. And I think speaking from personal experience, especially in the last couple of years, like we just introduced Attack for Cloud, it feels like ages ago, but in 2019, my own personal experience of like growing into the space, and I think you highlighted in your like talk really well, is complexity is very often the huge friction point of it's just so different, it's so new, it's a lot of the tried and true same techniques with a different spin. For folks in that same kind of space, like obviously we always throw around like read the docs, read the manual. Like, do you have any like tips, any advice for, maybe hypothetically, I got hired tomorrow at some company, and now I have this, hybrid environment with these workloads, and there's identity management. How do you acclimate yourself to your space to your point where you can actually start to threat model and maybe master the domain?
So that's actually one of the major benefits of the attack matrices in the first place. And it's like sort of the reason we are having this talk today. Like traditionally, we would always say first start with the associated attack matrices and the tactics and the corresponding security controls. The problem that we are identifying with cloud native is that like it's sort of nebulous, right? And it's like trouble trying to identify like what actually is applicable. And again, that's sort of what we're advocating for here today. Like this workload security matrix can help solve that challenges for people new into the space.
Yeah, excellent. And I love, I just read the caption on the QR code. Unfortunately, we are quishing here, so in the next couple weeks, you'll be able to tag this with a technique ID. But I love the spirit of that. That's something that we've always had as a bit of a challenge. Is CTI about Windows is dime a dozen everywhere. I love it. My personal favorite space, but easy to grep. Even today, we were just watching a report came out, some spicy stuff. But for the Linux space, it's a little bit maybe closer held. I think a lot of, I mean, obviously, no one would agree that adversaries don't operate on Linux hosts. I think we all know that. What kind of, I know, I love this call to action. I think it's a good step in the right direction. What kind of barriers do you see in terms of like the restrictions on threat and sharing that space? Is it mostly because it's happening in vendor environments and maybe not super transparency there? So what do you see as those kind of big barriers for sharing in that space, but also maybe some ways we can alleviate that going forward?
Yeah, no, I think that's a good point to highlight, is that there's so much vendor pushback and trying to understand and not being transparent about what may be happening. I think is a lot of it. I think, again, going back to the complexity, where do you start, right? How do you document that? How do you create a report on that when it's so difficult right now to understand what was used, when it happened, the ephemeral nature of containers? Putting that all together, it's really challenging to get all of that data to put a valuable report out.
Makes sense.
And to like add on top of that, some of it that we talked about is like how quickly the space moves in the first place, right? It's so easy to deploy something to the cloud these days that oftentimes organizations may not even be aware of like the threat that exists. And I think that is a large part of the problem, is that like, sure, some of this information is locked behind vendors and things like this, but I think a lot of the problem is that these attacks aren't being detected in the first place. We love to over-index on the threat of like installing crypto miners and things like that, but ultimately that is not the only threats that organizations face. And I think this over-indexing on like specifically detecting like resource hijacking is what causes some of this problem in the first place.
That's an excellent point, because one of the things that we've seen is we go searching threat intel about Linux, and very often you'll kind of run into the same thing, like SSH, valid accounts, crypto miner, and people think like that's not interesting. I don't care. Like, we absolutely call the community. We absolutely care, because very often we'll look at techniques and we're like, I don't know. We don't have any public reference of when the last time this was used. Like any type of prioritization, again, attack being a living model. It's always great we know those techniques aren't perfect. There's always additions, maybe new detection ideas, new mitigations. So the more context and color you can provide there, beautiful. So 100% appreciate the spirit. We do have a couple seconds. I'm going to give you one last type to plug. What's the best way? You mentioned kind of people getting into your repository and adding context or adding new ideas. How do you, any last bits about, just plugging that, or, how do you want people to engage? Just submitting pull requests or issues? Or
the easiest way is, like you said, to submit a pull request or an issue. Again, the first thing that we want to sort of acknowledge is that there's probably gaps in our understanding and awareness. With our organization, we get pretty good visibility to a lot of things, but that does not mean we can see everything. So this whole like idea behind community engagement is the biggest thing that we can advocate here. We need your help. We're asking for your help, and I think all of us together can combine to create something that can be useful to our to defenders and developers alike.
I think of a better way to end this. Thank you so much. It was excellent. A small token of our appreciation.